recording this. Alrighty, guys, so let's take a look at this. And I know some of this may be a little difficult to read with the small script, so I'll try to zoom in a little bit so at least we can get the main information for the problem. So this one, as you can see, is talking about a random sample of 1,007 adults in a certain large country were asked, do you pretty much think televisions are a necessity or a luxury you could do without? And then from that 1,007 adults, 524 indicated that this was the televisions are a luxury they can do without. So they're giving you the total sample size and then they're telling you, 524. So approximately half of them were like, yeah, television's a luxury we can do without. So you can see the first question they are asking us to calculate the point estimate for the population for the country, for the adults in the country who believe televisions are a luxury they can do without. So does anybody know how we calculate the point estimate? And if you guys have already been through the first homework section, then that might be, something you have already done. So point estimate, and you should be able to find these formulas, in the formula sheet or your textbook. Go ahead, Oliver.
The number of individuals in the sample divided by the sample size.
Very nice. Yeah. So since this is talking about people who believe that televisions are luxury they can do without, that would be our, what was that number? 524, I think. Yeah. So very nice. So yeah, that would be 524 divided by 1,007. And then you can see they're giving you your rounding rules right over here. So, we can just go ahead, take care of that division and we should have an answer. So can you guys tell me when we round this to 3 decimal places, what do we end up with?
.520.
520, alrighty. And I think I actually created a Google Sheet for this so that we could, just plug in all the different formulas we need and calculate that. Let me see if I can actually open that guy. Yeah, my computer is a little slow, so I don't know if you guys are getting any kind of lag or anything, but it's been rather slow today. Okay, so let me see if I can share this one with you. And you know what? Let me share this Google Sheet with you. So if you guys are, still working through homework and stuff, you should be able to use this. So in the chat, I will go ahead and send you the link to this Google Sheets. Okay, so you can kind of see, I took the formulas from your textbook and, I went ahead and put those in here. I think this is probably just scratch work or something I was doing, but we can take a look at that. So to calculate your point estimate, you have your X and N value. So that was our 524 for the X value. Our N was 1,007. So to calculate the point estimate, then all you need to do is, divide that 524 by the 1,007. And I know, Oliver, you already gave me that answer. So we had 0.520, rounding it to 3 decimal places. So 0.520. Okay, and then this is the part that we kind of have to, kind of go through some of the conceptual example for this one. So let's clear this out. So this one is talking about verify that the requirements for constructing a confidence interval about P are satisfied. So they want to know, can we assume, or is it stated or not stated, or cannot be assumed that we have a simple random sample? So if you look at the instructions, what are they telling us about this sample? The very first part of the problem tells us, right, that it's a random sample of 1,007 adults. So it's actually stating, so it is stated to be a random sample. Now, some of the things that you have to do when you are doing these type of calculations is basically figure out, and I think that's the second part of our worksheet over here, is write this little guy over here. So the idea is you take the n value, which is our 1,007, the point estimate, which we just calculated, which was the, the 0.520, and then you multiply that with 1 minus the point estimate value. And if that multiplication comes out to be greater than 10, and if we can say that our sample size is less than or equal to 5% of the population, then basically we can say, yes, we meet the conditions and we're ready to go ahead with these calculations. So that's kind of what this part B over here is talking about, verifying the requirements. So in this case, of course, we would say the value of, and this is where you're looking at this multiplication of n times the p hat times the 1 minus p hat. So that's the value we are looking at. And what will this calculation come out to be? So this is probably where I'm going to go back over here. And for the n times p hat, 1 minus p hat, let's go ahead and multiply. That's our n value is 1,007. We're multiplying it with our p hat value, which is this point estimate we just calculated. And then multiply that with an in parentheses 1 minus the p hat value. So again, you can type this in your calculator, or like I said, I just use Google Sheets or Excel to do all my calculations. And you can see this number is coming out to be 251 point something. So definitely it is greater than number 10, which is what we wanted this multiplication to be. So let's see what kind of rounding are they telling us about this. This is also 3 decimal places. So this was 351 point something. And let's see, that's coming out to be, will it let me make this guy bigger? I guess not. So this is coming out to be 0.3326. So since the 332 and there's a 6 after that, remember with rounding rules, we round up. So this guy becomes 0.333. So that's going to be our rounding rule over here, which is of course greater than or equal to 10 as the requirement is telling us about it. And then over here, this is where we want to make sure that our sample size is going to be, hold on, that should be less than or equal to 5% of our population size. So that's the second inequality over here that they want us to verify. So there's actually no calculation over here, guys, because what happens is they're not really telling us what the population of this large country is. So since they're giving you the idea that this is a large country, we make the assumption that, there's gotta be definitely more than 1,007 people in this country. So in this case, we will actually say that the sample size, so select that, can be assumed to be, so that's the option you're going to select, is that we're making the assumption that this can be less than or equal to 5% of the population size. So that's the part. And for most of these questions, you are going to make that assumption unless they specifically give you a population size. And I believe for most of these examples, they don't give you a population size. So it's safe to make that assumption. And then this is actually where we now get into our confidence interval. So they're saying construct and interpret a confidence interval for the population proportion of adults in the country who believe that televisions are a luxury they can do without, and they say, you know, choose the correct choice and fill in your answer boxes. So one of the things I will say right off the bat, see the two options you have over here? The first one is talking about there is a blank probability, the proportion of adults believe television they can do without. The second one says we are blank % confident that the proportion of adults in the country believe they can do without television. So remember, we're calculating the 95% confidence interval. You are not calculating the probability. So that probability is just there to throw you off. We are calculating the confidence interval. So just be sure about just selecting the right option. It's not a probability. We're talking about confidence interval. And they are telling us this is a 95% confidence interval. So we know we are 95% confident that the proportion of adults in the country who believe televisions are a luxury they can do without is going to fall between these two numbers. Now that's of course a calculation we will need to come up with. So remember, this is a 95% confidence interval. So the first thing we have to do is actually come up with our alpha value. And alpha is basically the calculation that we will need, and it will keep changing based on what your confidence interval is. So if it's 95%, the calculation for alpha is going to be 1 minus 0.95. So you're converting that 95% confidence into a decimal, right? So 0.95, and then you do 1 minus 0.95. So your alpha value is going to be 0.05. And then, I kind of wish this let me make my screen bigger, but it won't. So I'll just make the formula larger. So the reason why we're calculating alpha and alpha divided by 2 is you will see in this little formula here for our confidence interval, you have the z sub alpha divided by 2. And to calculate our z score, we need to know what that alpha divided by 2 is. So that's kind of where we are starting out with this problem. So right over here, once you calculate the alpha, then just take the alpha divided by 2. And of course, you can do that in one step. But this is the value that we need. So now we are actually calculating z sub 0.025 for us to be able to come up with the critical value. So let's come back over here, and you will see they're giving you links for the standard normal table over here. And what we need to do with that alpha divided by 2 value is what we need to find in the body of the normal distribution table. So we are looking for 0.025 in this table. And is it going to be in here? Am I looking in the wrong table? Hold on. No, because this one starts after 50%, so 0.05. So I was in the right one. Oh, there we go. I just missed it. I didn't even see it. Okay. I'm going to try and make this a little bit smaller. So remember, in the body of the table, we are trying to find 0.025, which is our alpha divided by 2 value. And it is right over here. So there's your 0.025. So you will see it corresponds with the z-score of, and we're not really going to be using negatives over here because we just need the critical value. We don't really care about the positive or negative. But in the table, you will see it corresponds to negative 1.9 over here. And then for the second decimal place, we are at 0.06. So your z-score for 0.025 actually comes out to be 1.96, ignoring the negative sign. So just look for that number. And 1.96 is that critical value that we are looking for. So that's what I'll place right here next to my z is 1.96, because again, that's a number we need for our calculation over here. So using the 0.025, we come and find our critical value. Now we are ready to look at this formula over here. So basically you can see we have a lower bound, which is the, the minus sign part of the formula on the left-hand side. And then the upper bound will be the p hat plus the z-score and all of that. So to calculate that, and I thought I had put my formula in here, but maybe I changed something. So let's go ahead and re-type that in. So remember, you start with p hat, and that's our point estimate value over here. And then from this, we are subtracting, and this is being multiplied. So the z-score is being multiplied with this square root over here. So we will do, the z value is our 1.96 multiplied by, and since everything else is in square root, you will use the square root function sqrt, and then in parentheses, you're going to have to do, all of this calculation. So that's going to be, again, p hat multiplied by 1 minus p hat. So you can see that gives us our numerator, and then divided by your n value, which is 1007. And again, guys, I'm just using the cells to do the calculations, but instead of the cells, you can definitely do the actual number. So you can use 0.520 for your p hat, do the 1 minus that number, and then, of course, whatever that answer comes out to be divided by 1007 for our n value. So whatever you are comfortable with. By default, Google Sheets and Excel should use order of operations. So hopefully, this will give us the right answer. And why did it not calculate? Unknown function B3. Is this guy on B3? Yeah, that's B3. Okay, I'm not sure why it is not accepting that cell, so I will just go ahead and put in 0.520 for now. Wherever I needed to have my p hat, I'm just replacing it with 0.520, and it's still giving me an error message. Okay, how about we put this part in parentheses, and it's still not working. Okay.
Sometimes my Google Sheets has issues reading functions if they're not in all caps. So the square root function might be the problem.
Ah, thank you for letting me know. I had no idea. Ah, nice. Okay, very good. Good to know. Okay, so if you can get the lower bound to work, just copy that function that you just, type that whole big thing in, paste it, and literally right at that first part where you have the p hat value, change that minus to a plus, and that's really the only difference between the lower bound and the upper bound. So you can see we can come up with how many ever decimal places they need, and that will give us our, the lower and upper bounds over here. And again, if you see, they're telling us to, if you have decimal answers, to round it to 3 decimal places. And that's exactly what we need over here. So our lower bound is 0.489 for this guy here. And then for our upper bound, we have 0.551. So 0.551. So basically what we are saying is that we know basically 0.52 or 52% of the population is saying that they are okay with televisions being a luxury and them doing without it. So the 95% confidence interval is saying that yes, from our survey we came up with 52%, but if we had to extend this to the entire population, right, to the entire how many ever adults live in this large country, we can say that anywhere from 48.9% to 55.1% of people are of this mindset. So we are saying if we had to extend this out to the entire population, it wouldn't exactly be 52%. It would be somewhere between 48.9 to 55.1. So does that kind of make sense of what the confidence interval is about? Yeah. Because, if you read the textbook, you will see that they talk about if you were to do, the sample size of 1007 in different groups of people, for each group of people, you're going to get a different percentage. So you won't always get that 52%. So each sample will give you a different result. So the confidence interval is kind of, okay, let's see what we can apply to the entire population for, and, come up with a reasonable answer. All right, so the next part is saying, is it possible that a supermajority, so that would be more than 60%, of the adults in the country believe that television is a luxury they could do without? Is it likely? So think about this. Our interval is 0.489 to 0.551. They're talking about, is it possible that we can have more than 60% who believe that luxury, TV is a luxury they can do without? So just looking at that range between the lower bound and the upper bound, what do you think? Is 60% possible? It's not possible, right? Because 60% is not part of that lower bound and upper bound, because it would be 60% would be 0.6, right? And you can see we stop at 0.55, so we're not going up to 60%. So we would say it is possible, because there's always a possibility, but it's really not likely that it's going to happen. So we're saying it is possible but not likely that a supermajority of adults believe they can do without the TV, because 95% of the confidence level does not contain 0.6. So we're converting that 60% into decimals. So remember, if this percentage that they're talking about, converted to a decimal, if it is within these two numbers, then yes, it is likely. But if it is not within that, then not likely. Okay, so that's kind of what we are doing over here. So let's go ahead, check this one, and then our last part, I believe this is the last one. I guess they don't really tell us. This one is saying use the results from part C, which is where we did the 95% confidence interval. Use the results from part C to construct a 95% confidence interval for the population proportion of adults who believe that television is a necessity. So remember, the two parts of the question was, and just looking at the question here, they said, do you think televisions are a necessity or a luxury you can do without? And this group of people, the 524, basically said it's a luxury they can do without. So now they want to know how many people think that television is a necessity. So how can we come up with that confidence interval is basically what they're asking us for this part E over here. And this one actually is very simple to calculate, because if this is the confidence interval for people who believe they can do without TV, then, subtract that from 100% and you will get, the remaining people who said, no, television is a necessity, I have to have it. So this is where you can do, and again, I'm just gonna, go back to my Excel Google sheet and use that to do the calculation. So I'll just do 1 minus oh, come on. There we go. Equal to 1 minus, and then we had 0.489 as our rounded answer. And then for the second one, that would be equals 1 minus, let's see, 0.551 is what we rounded to. And you can see that gives you the two lower and upper bounds for the people who think TV is a necessity. And they are falling anywhere from 44.9% to 51.1. So that will be your confidence interval. So really, it's this main calculation over here. If you can get by with that, then the others kind of just follow from it. So 0.449 for that first one. So, smaller number will be the lower bound, and then 0.511, I believe, is what we had. 511, yeah. And I think we should be good to go on that. Everybody okay on this example? Any question? No? Brittany, are you okay?
Yes, I'm okay. Sorry, I got a new software thing and it's just confusing.
Okay. Oh, I'm sorry. Okay, guys, so this was the one of the bigger problems that we have in 9.1. Now let's take a look at one example from 9.2. Trying to see. Yeah, I probably want to do this one. So that's number 13. Okay, I'm in preview mode. Sorry, I cannot save that. Okay, 9.2. And it's number 13. Does it not let me? Ah, there we go. Number 13. All righty. So this one is actually coming from, kind of very similar, actually. So let's see, again, I'll make this guy a little bit bigger. So this one is talking about trade volume of a stock is the number of shares traded on a given day. They're saying the data in the first accompanying table. So you can see the data over here in these tables over here. So they're saying the data in the first accompanying table is in millions. So that means 6.32 is actually 6,320,000 shares traded. They're saying they represent the volume of a certain stock traded for a random sample of 40 different trading days in a certain year. They're saying their second random sample is for 40 days in the same year, resulted in the data in the second table. And they're asking us to complete parts 1 through D. So let's take a look at this data over here. And you can kind of see, again, remember this is in millions of dollars over, how many days did they say? 40 days. And then here is the sample from our second table. So the first thing they're asking us to do is use the data from the first sample to compute the point estimate for the population mean of the shares traded. So what I'm actually going to do is see if I can copy this data. So let's make this guy a little bit smaller. And I think I have actually in that same sheet, I have included the number. Okay, what have I done over here? Give me a second, guys. I think I'm messing up something. No, I'm actually looking at the wrong problem. How did this one? Oh, yeah. Okay, now I realize because that one was such a large data set, I did not want to use that. Sorry about that, guys. Okay, so let's talk about this one. Pretty much the same thing, just with a smaller data set. So this one is talking about the pH of rain for a random sample of 12 rain dates. They're saying normal probability plot suggests that the data could come from a population that's normally distributed. They're saying a box plot indicates there are no outliers. So we've got parts A through D. Let's go ahead and actually copy this guy over. And guess I'm gonna paste it over here so we can do our little calculation. So the first thing we want to do is, of course, calculate our population mean over here, which, of course, will come from all of this. So that's your average function. And make sure we leave it as capital letters, as you mentioned. Okay, so we've got our mean. Now we need to do standard deviation. That's the, what happened? Sorry. And this will be, you know what? I'm just going to use the stdev function to do that. And we've got our 0.4204. Okay, so let's see for our point estimate. That's going to be our mean. So you are actually looking at okay, and I've kind of got the formulas over here just to show you what your textbook says, but then right next to it, you will see I'm talking about using the built-in functions, which is actually what we are doing just to save time over here. So for our X bar, we are going to have 5.105, I guess, if they want us to do 3 decimal places. Sorry, 2 decimal places in this example. So 5.10 then, I guess, for this guy. So you will just see how different between the two examples, your point estimate calculation was, that was the, the people in the survey who selected one option divided by the total number of your random sample. Here, it's technically the point estimate is your, population mean. Okay, so this part is saying same thing. Construct and interpret a 95% confidence interval for the mean pH of rainwater. And this one is talking about the 3 options. If repeated samples are taken, 95% of them will have, sample pH of this. There is a 95% confidence that the population is such and such, the population mean of pH water, and there is 95% probability for the true mean to be, whatever. So again, out of those 3 options, which one do you think makes the most sense for this example? A, B, or C? Repeated samples, 95% confidence, or 95% probability? Confidence interval, right, Sydney? Yeah, because again, you are talking about confidence interval. So we want to know, what those upper and lower bounds are going to be. So again, guys, don't let the extra stuff confuse you. You are still doing a confidence interval. And again, it is a 95% confidence interval. So like I told you in the last example, to calculate your alpha, you will do 1 minus 0.95. So again, you can see the alpha value will come out to be, what did I do? 1.95. Sorry, 1 minus 0.95. So your alpha will come out to be 0.05. And then, again, looks like I forgot to mention, but the alpha divided by 2, obviously same thing will come out to be 0.025. So now you are actually using this formula over here to now calculate our lower bound and upper bound. So instead of the Z value, you will see this example uses the T value. Now for this T value, we need to actually go to this critical value table over here. So you can see it's talking about the critical T values. And when we click on this guy, you will need to use the 0.025. And then did we talk about the degrees of freedom? I guess we did not. So degrees of freedom is right over here. The n-1 gives you the degrees of freedom. So again, if you look at the example here, they told us our sample size was 12 rain dates, right? We've got 12 different data values in here. So your degrees of freedom for this example will come out to be 12 minus 1, which is where we get the 11. And we need that degrees of freedom to find our T value over here. So you will see on the top of the T table, you have those alpha divided by 2 values. So right, we've got 0.025 right here at the top. Let me get my pen working. So here's our alpha divided by 2, and then you can see degrees of freedom is on the left-hand side, and there's our 11. So you need to basically see where those two rows and columns will come together. And it looks like it is 2.201. Just making sure I'm on the right path. So 2.201. Let's transfer that guy over here. 2.201 is our T value. All right, so we've got our X bar, which is the mean. We've got our T value, we have our standard deviation, and we have our N, which in this case, N is 12. So we should now be able to calculate this lower and upper bound. So let's do that. Okay, so let's start with the lower bound. You are selecting X bar, which is going to be our mean value over here. Same thing minus the T value, which we just found out to be 2.201. And then we are multiplying the T alpha divided by 2 with standard deviation divided by, and this time I will make sure I type it in with capital, square root of the N value, which is 12. So X bar minus T times standard deviation divided by square root of N. And that should give us our lower bound. And I'm just going to copy the same formula over, paste it for the upper bound. And like I told you last time, just change that minus to a plus and you have your upper bound. And that's kind of one of the reasons why I love using Excel or Google Sheets is, you can type in that formula once and not have to do the whole calculation again. So let's see, guys, again, our rounding rule is for 2 decimal places. So this guy will come out to be 4 point, and that's this number I'm looking at, 4.84. And for our upper bound, we have 5.37. Alrighty. Okay, so let's see what they're talking about here. Now they actually want us to do pretty much the same calculation, but you will see in this case, we're changing our confidence interval from 95% to 99%. So we're making that confidence interval even stronger. And so now we want to see how that's going to affect these upper and lower bound values. So let's take a look at 99% confidence interval. So coming back over here, you're basically repeating these same calculations that we just did. So your confidence interval is 99%, which means our alpha will be 1 minus 0.99 from our 99%. So you can see that comes out to be 0.01. Taking its half will of course give us 0.005. Your degrees of freedom still stays the same. So degrees of freedom is still 11. That hasn't changed. So can you tell me, by using 0.005 and degrees of freedom 11, what our t value should come out to be? And I'll make this guy a little bit bigger so you can see it a lot better. What will our t value be for this 99% confidence? So you've got 0.005 for alpha divided by 2, and then our degrees of freedom is 11. So what number do you guys select?
I see 3.106.
Alrighty, very nice. So 11 over here, 0.005 over here, and yeah, 3.106. Alrighty, very nice. So as you can see, since your t value is going to change, obviously our interval will also end up changing. So 3.106, let's go ahead and put that in here. So honestly, a lot of our formula is still going to stay the same. And let's do it over here. We've got our lower bound, upper bound. So, X bar, of course, is still going to stay the same. So X bar is still this 5.104 whatnot over here. Multiply that by, God, I cleared this out. All right, multiply that by our t value, which is the 3.106. Sorry, not multiply, subtract. Subtract, and then multiply with our standard deviation divided by the square root of n, which of course also stays the same. And you can see there's just a slight difference in the values we got from the 95% confidence interval to the 99% confidence interval. So again, keeping everything the same, just change the plus to a the minus to a plus, and you've got 54.8 to, well, 4.73 to 5.48. 4.73. And again, guys, you are still doing a confidence interval. So even though they're changing the orders here, you are still good to go. So what was that? 4.78? Sorry, 73. And then for the upper one, we had 5.48. Okay. So let me ask you here. What do you notice between your lower and upper bound as we change our confidence interval. If it will let me bring both of them on the same screen. What do you notice between the lower and the upper bounds as we change our confidence interval?
The decimal values are swapped essentially.
Oh, that's interesting. I didn't even notice that. Wow. Yeah, the 3-7 became 7-3. Oh, wow. Oliver, that was a good observation. But your gap becomes wider, right? I mean, at 95%, we were at 4.8 to basically 5.4, or 3.7, because I guess the numbers are pretty close. But you will see just a little bit of a widening when you increase your confidence interval. So actually, that is something that you will notice. A lot of times we do 90% confidence, 95%, 99%. Sometimes they will do 97%. So yeah, as you change that degree or the level of your confidence, the interval will actually switch also. So it's kind of interesting when you notice that. And that's what they're asking you in this last part over here. So they are saying what happens to the interval as the level of confidence is changed. So we are saying as the level of confidence increases, because we went from 95 to 99%, the width of the interval increases, right? Because it became wider. The width increases, and they're saying this makes sense since, and you have to choose, is it the margin of error, sample size, or point estimate? So they're saying this makes sense since, well, what increased? Did the margin of error, sample size, or point estimate increase or decrease? So think about this. Did our point estimate change when we changed our confidence interval? That was the population mean. No, it did not change. Did our sample size change? No, we were still using the same 12 days. So really, it's your margin of error, because you're going from 95% to 99%. So yeah, you're actually changing your margin of error. And of course, your margin of error is also increasing as you increase your confidence interval. So all of these are tied in together. Okay, where's my check? There we go. So it's just, they're using two different distributions over here. The 9.1 example we saw was using the normal distribution table. And then in this section, we use the T distribution table. But you can see, essentially your calculations are going to be very similar. It's just depending on which example you are looking at. You can be using T distribution, or you can be using, the Z distribution that you have over here. Now, guys, I have actually also included two other examples. If that's something you are interested in working through, you can kind of go through them and look at those calculations. But those ones actually are the smaller problems. These two were definitely the bigger ones that I think take a little bit of time and, those multiple steps to go through. So any questions on this example or the one we just talked about? Okay, so like I said, if you're still working through homework and you have any questions, please don't hesitate to reach out and ask for help. Just keep in mind, again, you don't have any D2L assignments this week either. So there, obviously, there were no discussion posts or any other assignments. So please take this week to get whatever you can get done with your chapter 9 and 10 homework, take your quizzes for the 2 chapters and then your exam. And then next week, we will be doing chapters 11 and 4. Like I said, total together, you only have 3 sections for those 2 chapters. So I would say if you can, try to use the first part of the week to get that homework out of the way. So, get chapter 1 and 4 done maybe in a couple days or whatever you can do comfortably. And then use the rest of the week to get caught up on any older assignments, to study for the final, wherever you find yourself next week. If you don't have anything you want to go back and work on, if you don't want to take an exam, that's okay. Remember, this is all optional for you. So don't feel any obligation like, oh, I want to go back and rework on anything. If you want to, you have that available to you. But definitely, please prepare for the final exam also as you're getting into next week. And just to let you know, your final exam is in 2 parts because we only meet for an hour. We cannot do our traditional exam like we would do, if we were like on campus or something like that. So what I've done is I've taken the smaller, less complicated questions, I guess, and I've put them in the in-class version of the exam. So that last class we meet is where you do the in-class version of the final. And then you actually have a little bit of a longer exam, which you guys do at home, and you get 48 hours to work on the exam. However, it does not mean you can extend the exam for 48 hours, right? It just means you can choose whenever you want to sit down between those 2 days to take your exam, but you still have to take it kind of like at the same time, right? And I don't remember, you may have 2 hours or a little bit more than 2 hours to do the the take-home version of the final. You can use notes. You can obviously use Excel or Google Sheets to do your calculations like you did for all of these assignments. Calculators, scientific or, oh my God, that name just flew out of my head. Graphing. Yes, you can use scientific or graphing calculator. You can keep your notes with you. You can have the formula sheet, whatever resources you need. But, obviously turn in your own work, not somebody else's work or something you've copied off. You use the resources that are available to you, your textbook, your notes, formula sheets. Like I said, Excel, Google, calculators, but, obviously turn in your own work. And then if you guys have any other questions, I'll stick around for a couple more minutes, answer any questions you have. And if not, then I will see you guys next week. Okay, if you don't have any questions, then have a wonderful evening, guys. Be careful, and I'll see you next week. Bye, everyone.
I have a question. Sorry.
Yeah, no